One of the great things about Ruckus Gear is its flexibility. You aren't bound to any one particular type of architecture. With one single system, you can actually choose from multiple architectures. Some of the things we're going to be looking at is just the different types of architecture and the different types of setup that you'll find within the Zone Director system. So we'll talk about everything you see on this list. Some of the highlights will be the wired topology, the data forwarding model, and how those different things can be configured to accommodate your particular network. The basic network architecture is, in this example, when your access points are wired. The access point in this case has just communicated with the Zone Director. This is all done automatically. You don't have to pre-provision it to do that. The next thing is it gets its configuration and its firmware. So it receives its firmware from the Zone Director and to match the Zone Director. So if you've upgraded your Zone Director to the latest code and then you plug in an older access point with older code, it automatically upgrades. The next thing is when a device tries to authenticate. So in this case, a client has connected to an access point. That goes to the Zone Director. So all security authentication goes to the Zone Director. The Zone Director queries your Radius server or your Active Directory system to authenticate that client. The client is then allowed to pass regular data over the network. So, pretty simple system. As far as flexibility on the wired side, the easiest one and the most common is just a layer 2 flat topology. What this means is all your access points are just connected by wire, of course, to your Ethernet switch. Nothing really complicated there. Once you plug it in, the access points contact the Zone Director like we saw in the last slide. Everything's up and running. But in larger networks, you'll find that you'll need to do some layer 3 provisioning, layer 3 topology. Now, what you'll see there is multiple access points connected to a router. So let's say you have multiple buildings within a campus, and each of those is on a different layer 3 subnet, then each of those access points, the access points in those respective buildings will communicate over a routed network back to the Zone Director. Again, the great thing is with a little bit of pre-configuration in your DNS server or your DHCP server, this will happen again automatically without pre-provisioning. Another great part of flexibility with Ruckus is mesh. So in this example, what mesh would do is we would wire an access point per floor. Now, a lot of times, say hospitality or even healthcare, you'll find that it's very difficult to wire extra access points. So very simply, all you do is deploy these other access points after provisioning, and provisioning just means you plug an access point into the wire for, say, 5 minutes, it gets its upgrade, it gets its configuration, it gets its mesh algorithm, and then it goes in and you physically just plug them into wall and you're powered up mesh. So the advantage is it's self-healing, it's self-meshing, there's no configuration once you get it up and running, once you physically plug it in. You can add capacity without added very expensive wiring. You reduce your costs on switching and like I said, wiring. It's secure automatically, so each of these in a typical environment will be secured with AES encryption. You can set your own key or the system will automatically generate it for you. Now, a really important distinction in the marketplace today is data forwarding models. So this particular type, called local bridge mode, is something that is very important, especially with today's 802.11n technology. Distributed forwarding means that all of the traffic that goes from a client to an access point goes out regular layer 2 Ethernet of that access point. Now, that sounds pretty normal, just like any normal standalone AP, and that's correct. The advantage to this is it uses the normal Ethernet infrastructure that was designed to handle lots of data. The other type is centralized forwarding. Centralized forwarding is when all of the data gets tunneled back to a centralized controller like the Zone Director. Now, looking at this on a bigger scale here, a diagram, we see that this client is connected through the local bridge mode. What this means is every time this client communicates, it actually goes right from the access point, wirelessly to the access point, and directly out the network, whether it's to the internet or to a local resource. It does not go through the controller itself. However, in some cases, you would want some of the data to go through the controller. As an example, any kind of tunnel mode with voice over IP. So if you want the ability to roam between multiple subnets, you'll notice that these two sections are on two different subnets. If you want to roam, like is quite common with voice, the system will tunnel it through the controller and then back out that specific interface, out the interface of the zone director. So a good way to compare that, and let's look at roaming here real quick, a good way to look at this is when we roam, this device doesn't actually know that it moved. Notice that even though it's on this subnet now, it has an IP address from the other. What that means is you don't have any layer 3 drops as you're roaming from access point to access point. Now, one of the things to consider is it's important to understand where does the network live, and this is something I talk about quite a lot. In this mode, where does the traffic actually enter the network? Well, the answer is out the access point's Ethernet port. That's where it actually enters the network. So any DHCP requests come from here. Any normal traffic comes from this access point's Ethernet port. But in tunnel mode, even though the data is going through the access point and out its Ethernet port, it is being tunneled or encapsulated where it goes into the controller, and then the controller does what it's doing, in this case with roaming, and then out the Ethernet port. So what you're seeing here is the data is actually, any data that becomes live on your network actually comes from the zone director's Ethernet interface. So for example, in non-tunnel mode, in bridge mode, if you're going to set a VLAN on your switches, you would set it on the switches connected to the AP. If you want a VLAN tag in tunnel mode, you'll VLAN tag coming out of the zone director interface. So I know they can get kind of complicated, but the advantage is extreme flexibility. Now this is done on a wireless LAN basis. This isn't something you put an access point into one mode or the other. So this access point, in the zone director, you just say, I want the voice wireless LAN tunneled, but I want everything else done through distributed forwarding. Again, this is the ultimate in flexibility. You can tunnel some traffic, but not others with just one checkbox in the zone director. Multiple SSID support or multiple wireless LAN support is pretty common today. Our zone directors will do 32 wireless LANs on the zone director itself, 8 wireless LANs per radio. So if you have a dual radio access point, that's 8 SSIDs per radio, not per access point. So each of these, it's pretty common to do multiple SSIDs. This chart is a good example of that. So what we have here is an SSID called CorpNet, another called GuestNet, and another called Contractor. So very simply, you create all 3 of these. You can tag each of them separately, which is pretty common to do. Set security differently. So on a guest network, you're going to have maybe no security, which is pretty common, but that VLAN is going to tag it right out to the internet. So that tag is pointing to a basically, or through your firewall, where you don't have to worry about security because it's going right to the internet. The other advantage is captive portal mode. Are you going to do web authentication, guest pass, which maybe have a time limit on it, or maybe no captive portal on the internal corporate? The other advantage you can do inside of here is rate limiting. Internal customers, internal clients, no rate limiting. Give them as much throughput as you want. Guest network, restrict them pretty tight, and then contractors, maybe you give them a bit more speed. But all of this is done in one screen. The implementation, when you say, I want this SSID to have this tag, this type of authentication, this captive portal mode, and this rate limiting, is all done on one simple screen that you'll see in other segments. You can also provision access points into separate groups. So you can actually have different sets of access. As an example, let's say you are in a healthcare situation and you want to have one group of access points in one area to be available for the radiology department. But you don't want that SSID broadcast in another department in a different building or maybe on a different floor. You can create wireless LAN grouping very, very simply, where you group and you say this group of access points, in this case we have 2 access points here in one particular group, wireless LAN group 1, which contains 3 wireless LAN SSIDs, so 3 SSIDs here. But maybe on this one we didn't want the guest SSID. We didn't want them to be broadcasting, these devices to be broadcasting different SSIDs. So you have the ultimate manipulation depending on location and what you want to serve in what areas. Fault tolerance is obviously very important. Now, the great thing about the zone director is if you lose the zone director, your data in the distributed forwarding model you don't lose anything. Since our access points act as standalone when in distributed forwarding mode, that's non-tunneling, bridge mode, that when they're doing that, if you lose the primary zone director, nothing changes. The only thing that can't be done is you can't authenticate new customers for that time. So most people tend to choose to have multiple zone directors, so redundant controllers. In this case, smart redundancy gives you an active zone director that's operational and everything's fine. But if something happens to happen to this zone director, it fails or the power goes out on it, the access points already have in mind that there's a second. They've already been told that. These two have been synchronizing the whole time. Everything's been fine. The same exact system, dynamic PSK, all the features you get in the zone director, mesh algorithms, are all synchronized across these two devices. So as a device, this first primary controller goes down, the other access points find out about that, and they connect to the secondary zone director. And location support services. AeroScout is a company we've partnered with. So if you have devices to do Wi-Fi based RFID or real-time location services, again, a lot of stuff you'll find in manufacturing and healthcare, those type of things are done through the zone director with the AeroScout engine. So what we do is with one checkbox in the zone director, you say, enable AeroScout location tracking. And what that gives you is all the data that's sent from the sensors, whether they're environmental or location tracking, whatever they may be, once that hits the access point then already has the signatures and sends it right over to the AeroScout engine. So as you can see, there are a lot of flexible deployment options. You're not bound by one system or another just by what you purchase. Once you get the Ruckus Zone Director system and all the access points that go with it, you have the flexibility to deploy in multiple architectures whatever is best for your particular environment.